In this video I will discuss some of the topics covered in the public lecture by Dr. John DePillis given in Clough this month, April. So the topic covered in the lecture is called Illustrated Special Relativity Through Its Paradoxes. It was actually kind of hard to follow what the topic was telling us, but basically the idea is that using basic linear algebra as a natural language of special relativity and assuming very little knowledge of physics, a novel was presented to us. In the novel, linear algebraic derivation of Lorentz transformation is covered, and also Minkowski diagrams were shown to us. What I really liked from the lecture is the fact that Dr. DePillis showed us some interesting examples with cartoons that he actually drew himself, and also I really like linear algebra, so I enjoyed parts of the lecture, actually the parts that I understood. Talking about Lorentz transformation first, it was actually taught to us that the speed of light is independent to the reference frame, and we were shown various examples. The one I liked was the one shown from a slinky falling down, and Dr. DePillis chose a reference frame and he showed us how the speed of light is independent to such frame. The second topic covered was Minkowski diagrams, as I've mentioned, and basically what we saw was that the use of linear algebra can help us define that one of the angles shown in this picture of one of the lines is equal to the angle made by the other line crossing, and what is hard to tell is the position that one of the lines has to take so that both angles are equal, and we were taught this in the lecture. There's a follow-up question that came to mind to me after the lecture, and it was actually derived from a conversation I had with a friend who's taking Physics Honors 1, and he was talking to me about an example of Lorentz transformation in which an object is moving so fast that compared to its reference frame, it's actually possible to say that the object is a little bit amount of time ahead, so the object is actually in the future. There's a delta t 0.0 something after, so I don't really understand this, but it's actually interesting to talk about it, and hopefully in the future I'll be able to learn more about it. As I've mentioned, the public lecture gave a hard topic to understand, an advanced topic, but hopefully I shown what I learned from it, and hopefully I'll learn more in the future, and this is what I've got. Thank you very much.